Swayam Prabha. Digital India. Educated India.
Welcome to lecture 39 of the course on multivariate data mining, methods and applications. The title of this lecture is block clustering. In the usual clustering methods, we cluster the observations according to cases or according to variables. Means in each cluster, we classify the observations which behave in a similar fashion, or we classify the variables which behave in a similar fashion or which follow the same pattern. Similar kind of pattern. So, basically the classical clustering procedures are one-way clustering procedures. In bi-clustering or block clustering, we classify the observations according to both rows and columns, that is, according to cases as well as according to variables. So, the observations belonging to a particular cluster are the group of cases which are behaving in a similar fashion, and it also involves a group of variables which follow the same pattern or which are behaving in the same manner for these cases. So, now we consider block clustering or bi-clustering or co-clustering. So, the traditional clustering methods cluster either rows, that is samples, or columns, that is features or different variables of a data set. And then the cases or rows belonging to a particular cluster, if the clustering is according to samples, then the cases belonging to a particular cluster are those cases or those samples which follow the similar kind of pattern or which are behaving in a similar manner. And if you are clustering according to features or variables of a data set, then you get a group of features which behave in a similar manner. Now, the objective of block clustering is to identify subsets of both rows and columns that exhibit similar behavior or patterns. So, now you are interested in both rows and columns. So, a particular block of cluster is a subset of rows as well as the columns, and the subset exhibit similar behavior or patterns. And the block clustering actually operates on a two-dimensional data matrix, where rows represent samples or cases or objects, and columns represent features or attributes. Then each entry corresponds to the value of a particular feature of a given sample. So each entry of the data matrix actually is corresponding to a particular feature for a given sample. And then by clustering, we partition both the rows and columns into coherent blocks or clusters. These coherent blocks are the clusters. Further, each block represents a subset of samples and a subset of features that exhibit similar behavior or pattern. So, in classical clustering, each cluster represents a subset of samples which are exhibiting similar behavior or patterns. Or if you are clustering according to features, then each subset of feature represents a group of features which are exhibiting similar kind of pattern. So, the block clustering actually produces a simultaneous reordering of rows and columns of R cross N data matrix X, so that the data matrix is partitioned into, say, capital K submatrices or data clusters. So, instead of partitioning either rows or columns, now we have partitioned the entire data matrix into capital K submatrices, and each submatrix actually represent a subset of rows and a subset of columns. Then each entry appears in one and only one data cluster. So, we are taking each entry into one and only one data cluster, and each data cluster corresponds to a particular row cluster and a particular column cluster. So, if there is a data cluster, then the rows of this particular data cluster may be considered as a particular row cluster. Further, the columns of this data cluster may be considered as a particular column cluster. Then in the algorithm, we of course require a similarity or distance measure between rows and between columns. So, we use such kind of similarity measure in the algorithms. Now, one can use various algorithms, including hierarchical clustering or K-means clustering, and by clustering specific algorithms such as plate model. We will discuss different plate models in the next lecture. Then the simplest way is apply hierarchical clustering method to rows and columns separately. You have a data matrix, then you can apply hierarchical clustering to different rows, and you can also apply the hierarchical clustering to different columns. So, it is actually two-way hierarchical clustering, and ultimately it will lead to block clustering. Now, we have considered the empty cars data set. Again, since we have used the empty cars data sets in various previous examples, so I am not going to discuss this data set in detail here. And then we have applied separate hierarchical clustering of rows and columns to empty car data sets. And then in this heat map, high values are in red and low values are in yellow. Or this is also the heat map for the same data set. Now, using that heat map, you can observe different patterns in terms of groups of cars as well as in terms of groups of features. Say, if you consider a group of cars, then it represents or it reveals patterns in terms of groups of cars sharing similar characteristics across multiple features. Say, for example, one bike cluster might include a group of fuel-efficient, lightweight, compact cars and high miles per gallon, low horsepower and low weight. So, suppose you have a group of cars which are fuel efficient, lightweight, compact cars, and then these cars have high miles per gallon or low horsepower or low weight. Then you may classify those cars as, say, compact cars, or you may classify those cars in a single group. Further, if you consider the hierarchical clustering according to group of features, then it may reveal patterns in terms of how features behave across different car models. Say, there might be a group of features which are behaving in a similar manner or which are following a similar kind of pattern across a group of car models. So, you get a cluster there. So, suppose for example, a bike cluster might include features such as horsepower, weight and displacement that tend to vary together across different car models. Say, if you consider horsepower, weight and displacement, and then you observe that displacement, horsepower and weight, these are behaving in a similar fashion for different car models. So, for this car also they are almost behaving in a similar fashion, or for this car model also. So, you may find a group of cars which are behaving in a similar fashion according to these three features. And then this group of car models indicate a relationship between engine size, weight and power output in determining the car performance. Now, there are various applications of block clustering. Say, gene expression data or gene expression analysis. We identify groups of genes that are co-expressed across different experimental conditions and groups of samples that exhibit similar gene expression profiles. So, suppose you have different experimental conditions and then you identify a group of genes that have co-expressed together. across different experimental conditions. And then suppose you identify groups of samples that exhibit similar kind of gene expression profiles. So, you want to group the gene expression data according to gene expression values as well as according to samples. Under certain conditions, under certain experimental conditions, a group of samples is having a similar kind of gene expression profile. So, you are interested in finding that group of experimental conditions as well as that group of samples also. Text mining and document clustering. Identify groups of documents with similar content and terms, and then by simultaneously clustering both terms and documents, it reveals topics or themes that are specific to subsets of documents. So, basically, you have information on content and terms, and then you want to identify the groups of documents which are similar to both content and terms. And if you succeed in finding such kind of clusters, such kind of groups, then it reveals the topics or themes which are specific to that particular subset of documents. And you can use this kind of information obtained from the data for document organization, topic modeling, and information retrieval tasks. Image processing and computer vision. So, image segmentation or object recognition and pattern analysis. So, basically what you have to do, you want to identify subsets of pixels or image regions exhibiting similar visual characteristics across different images. Now, for this purpose also, the block clustering helps. Ultimately, you have to cluster or segment the image in both the directions. Say pixels or image regions and across different images. So, different images. Now, this kind of analysis helps you in detection of objects, textures or structures that are consistent across different contexts. So, basically this kind of block clustering helps you in identifying different kind of structures which are consistent across different contexts. And then one can use block clustering for the market basket analysis. So, you have observations on the products purchased by different customers. Now, you are clustering in both the directions, customers and the products. Then the by clustering reveals associations between specific customer segments and product categories. You have a particular group of products in which the customers of a particular segment are more interested. So you are interested in both, say in that group of product also and the group of customers which are interested in that particular group of products. And this kind of analysis helps in targeted marketing or cross-selling and product recommendation systems. You can recommend that particular group of products to the customers belonging to the segment who are more interested in that group of products. So it helps you in targeted marketing. Then for biomedical data analysis, say you identify subsets of patients and biological features that are associated with the specific disease or drug responses. So you have observations on different biological features, and then you also have different patients for which you have the observations on biological features. And these biological features are associated with some specific disease or response for the drug. Now, it may happen that a particular subset of patients belonging to a certain race may have different kind of response, means that particular group has a similar kind of response to a particular group of biological features, whereas the other patients don't have the similar kind of response, they have different kind of response for that particular group of biological features. Identification of patient subtypes, biomarker discovery, and the prediction of treatment outcomes. So, such kind of analysis helps you for all these purposes. It helps you for the prediction of treatment outcomes. Now, you can say that that particular subset of patients may respond well to the drug, provided they have that particular group of biological features also, or they are more prone to disease, a particular disease, if they have a certain group of biological features. Sensor network and Internet of Things data analysis. So, we can use block clustering for analyzing spatiotemporal data collected from sensors deployed in different locations. So, it helps to identify subsets of sensors and time intervals that exhibit similar measurements or patterns. So, again, block clustering helps you for this kind of sensor networks analysis. Social network analysis. To identify communities or groups of individuals with similar behavior or interactions. So, you have individuals as those, and then information on social interactions as columns. And suppose you bicluster this data, then you get the information which subgroups within the social networks are more cohesive, means for a particular group of interactions, social interactions, those or that particular group of individuals is more similar or follow the same pattern. Now, we consider Hartigan's block clustering algorithm. In Hartigan's block clustering algorithm, we start with all data in a single block, say capital K equal to 1. Now, suppose B1, B2, B capital K be a partition of the rows and columns of X into capital K blocks, where Bk is equal to Rk Ck. So, Bk is consist of a set Rk of small Rk rows and Ck is the set of small Ck columns. So, basically this Bk is consist of a subset of rows and a subset of columns. It has small Rk rows and small Ck columns, and this capital Rk denotes that particular subset of rows and capital Ck denotes that particular subset of columns for all small k equal to 1 to capital K. Now, for Bk, we compute the mean of all xij's in Bk and we denote it by x bar k. We take all the observations belonging to this particular block and then we obtain the mean of all those observations, and this is the mean. Then the other sum of squares ESS is summation k equal to 1 to k. We take summation over all the clusters and then summation over ij belonging to Bk. So, we take summation over all the observations belonging to the block Bk. Xij minus x bar k. So, we take deviation of each observation from that particular block mean and then we take a square of this. So, this gives you the error sum of squares, or this is actually within block sum of squares, total within block sum of squares. Now, at the hth step, you have h blocks, say B1, B2, Bk, so on, Bh. And now, suppose you want to split Bk into two sub blocks Bk dash and Bk double dash. And you can split Bk into two sub blocks either by splitting rows or by splitting columns. Say we have split BL, that is RLCL into BL dash, which is equal to RL dash CL dash, and BL double dash equal to RL double dash CL double dash. Then the only row split allowable for Bk is a fixed split given by Rk dash equal to RL dash and Rk double dash equal to RL double dash. So, keep this in mind. If Rk already contains a previous row split, then here for the row split, we put this constraint Rk dash equal to RL dash and Rk double dash equal to RL double dash. Similarly, for the column split also. And then a free split is a split in which no such restrictions are specified. Then we consider the reduction in error sum of squares due to row split. So, we take the difference between error sum of squares before the split and after the split. Now, before the split, the error sum of square is given by this term, summation over k, summation ij belonging to bk, xij minus x bar bk whole square. Then we have split this particular block bk using a row split, which results in two blocks bk dash and bk double dash. Now, in bk dash, the error sum of square is summation over k, summation ij belong to bk dash, xij minus x bar bk dash whole square. And for bk double dash, the error sum of square is, so we take minus here, summation over k, ij belonging to bk double dash, xij minus b x bar bk double dash whole square. We divide the first term into two parts. So we take summation over k, summation ij belonging to bk dash, xij minus x bar bk whole square, plus we have this term here, summation over k, summation ij belonging to bk double dash, xij minus x bar bk whole square. And then we write this term here and this term here. Now, in the first term, what we do? We subtract x bar bk dash and then we add x bar bk dash. And the second term remains the same as earlier. In the third term also, we subtract x bar bk double dash and then we add x bar bk double dash. And this fourth term remains the same as earlier. Now we write this first term as summation over k, summation over ij belonging to bk dash, and then we take square of this term. So we get xij minus x bar bk dash whole square plus you have summation over k, summation ij belonging to bk dash, x bar bk dash minus x bar bk whole square, and since here the subscripts ij are not involved, and in fact k is also fixed, means you are taking the mean. So we get ck rk dash. Ck is the number of rows and rk dash is the number of columns. So you get ck rk dash x bar bk dash minus x bar bk whole square, and then this term will cancel out with this term. Similarly, you can simplify this term, second term also, and then again this term will cancel out. So here we get ck rk double dash x bar bk double dash minus x bar bk whole square. You also have the cross product term, but you can easily verify that the cross product term vanishes. You just make use of the result that sum of deviation from mean is equal to 0. So at each step we compute delta ESS for each row or column split of all existing blocks, and then we choose a split that maximizes delta ESS, and then we stop when any further splitting leads to delta ESS becoming too small, or when the number of blocks k becomes too large. So, we stop there. So, this is Hartingale's clustering algorithm, block clustering algorithm. Now, we come to biclustering. We divide R cross N data matrix X into a pre-specified number of biclusters. Then each bicluster is a subset of samples having a high degree of similarity. Then the biclusters don't have to be disjoint. So, this is how biclustering is different from previous block clustering. Some rows and columns appear in several clusters. So, basically bicluster is a subset Xij of X, where capital I is the subset of Ni rows of X and capital J is the subset of Nj columns of X. Say, suppose Xij is the expression label for I belonging to capital I, J belonging to capital J. Now, for bicluster, we consider this two-way ANOVA model. So, suppose the model for bicluster is two-way ANOVA model given by Xij equal to mu plus alpha I plus beta j plus epsilon ij for all I belonging to capital I and j belonging to capital J. Here, mu represents the overall mean effect, epsilon ij is the error, alpha I is the ith row effect, and if we take summation of alpha I for all I belonging to capital I, then we get 0. Further, beta j is the jth column effect, and summation of beta j is also equal to 0. And then suppose x bar I dot is equal to 1 upon Ni summation over j xij, and x bar dot j is 1 upon Nj summation over I xij, and x bar dot dot is the overall mean, that is 1 upon Ni Nj summation over I summation over j xij. So, now we obtain the least squares estimates of mu, alpha I and beta j, and for that purpose what we do, we take the sum of squares, we take summation over I summation over j xij minus mu minus alpha I minus beta j whole square, and then we differentiate it with respect to mu, alpha I and beta j, and we then put those differential coefficients equal to 0. We solve the equations for mu, alpha I and beta j, and we also use these constraints, and ultimately we get these least square estimators for mu, alpha I and beta j. Mu head is equal to x bar dot dot, alpha I head is equal to x bar I dot minus x bar dot dot, and beta head j is equal to x bar dot j minus x bar dot dot. Then we can find the estimated residual also, which is denoted by epsilon ij head, and epsilon ij head is equal to xij minus mu head minus alpha I head minus beta j head. Then we substitute the values of mu head, alpha I head and beta j head, and after substituting the values from here, we obtain epsilon ij head equal to xij minus x bar I dot minus x bar dot j plus x bar dot dot. And then you can easily find the residual sum of squares for the bicluster, which is RSS ij equal to summation over I summation over j epsilon ij head square. So, we get this expression for the residual sum of squares. Then the objective function is hij equal to RSS ij divided by ni and j. Then hij as proportional to residual mean square of bicluster is, say, RMS ij equal to ni minus 1 and j minus 1 upon ni and j h. Then the objective is to find set I and j so that hij has a small value. Then bicluster is constructed sequentially by deleting one or multiple rows and columns at a time from x, and the row and column at each step are chosen, giving largest decrease in the value of hij. Now, your objective function is hij. So, we consider the decrease in this value, and then we fix maximum acceptable threshold value, say delta greater than or equal to 0 for h, and the elements of x corresponding to each bicluster found are replaced by random numbers so that no pattern from the bicluster is retained. Then next bicluster is solved. So, this is how we go for biclustering using the objective function hij. So, here we have considered an example in which we have applied biclustering for randomly generated data, and we have generated data from the normal distribution, and the first two cluster sizes are these. In bicluster 1, you have 4 rows and 10 columns. In bicluster 2, you have 6 rows and 10 columns. And then we shuffle the data, and ultimately we arrange the bicluster as one cluster which has 10 rows and 10 columns. Now, here is the heat map. The heat map actually represents the data matrix. Each row of the heat map actually corresponds to one of the observation, and each column corresponds to one feature or variable. Further, the intensity of colors indicate the value of the data at each cell. Usually, lighter colors represent low values and the darker colors represent high values. Then the biclusters represent subsets of both rows and columns that exhibit similar patterns. Each bicluster is actually depicted as a contiguous block of cells within the heat map, where the colors within the block are relatively similar compared to the rest of the heat map. Then this heat map, if you look at the cells which are dark red in colors, then those cells are corresponding to the bicluster. Now we can represent the heat map in this form also, just by rearranging the rows and columns. The advantage of this representation is that all the rows and columns or all the observations and features belonging to the bicluster are now depicted at a single place. So here you obtain a particular bicluster. Now we consider this example of biclustering of yeast dataset. So we have bicut yeast gene expression dataset, which is obtained from experiments measuring gene expression levels in yeast cells under various conditions or treatments. Further, this microarray data matrix is for 80 experiments. Then we have expression levels of 419 prop sets over 70 conditions. And then we have performed the biclustering for this yeast gene expression data set. And ultimately, it identifies 5 biclusters. The first bicluster has 23 rows and 7 columns. The second one has 29 rows, 8 columns. The third bicluster consists of 2 rows and 7 columns. Fourth bicluster has 4 rows and 10 columns. And the fifth bicluster has 79 rows and 4 columns. So in all, it has identified the 5 biclusters. Then here is the heat map of yeast gene expression data set. And from this heat map, you can identify the observations which are behaving in a similar manner under certain conditions or under certain features. So you can easily identify the bicluster. Say here you obtain a particular bicluster, or here also you obtain a particular bicluster. In this lecture, we have discussed biclustering. Biclustering is different from the usual clustering methods in the sense that in usual clustering methods, either we perform clustering according to rows or different cases, and then we group similar cases or the cases following similar kind of pattern into one cluster, or we perform clustering according to different columns or different features, and in that case we group the features behaving in a similar manner into a particular cluster. In biclustering, we consider both the rows and columns, that is, cases and features for applying the clustering. So, the data points or the elements of a particular cluster behave in a similar fashion according to different features, and the cases belonging to a particular block cluster behave in a similar fashion or follow a similar pattern according to features for that particular block. So, we are clustering the observations according to both cases as well as features. We have also discussed Hartingen's clustering algorithm, which one can use for the biclustering purpose. And then we have discussed the block clustering and two-way ANOVA model for block clustering. In the next lecture, we are going to discuss played model for biclustering. I am going to stop here. Thank you.
am Chitwan Lalji, a PhD student of Health Economics under the supervision of Dr. Debayan Pakrashi from the Department of Humanities and Social Sciences, IIT Kanpur. In one of my essays, I am interested in understanding the relationship between consumption of fruits and vegetables and various health indicators. Health indicators, both subjective and objective health indicators like mental health, self-assessed health, various measures of blood pressure and various measures of cholesterol. Measures of blood pressure like systolic and diastolic BP. You have your incidence of high BP, MAP and incidence of high MAP. And as far as cholesterol is concerned, I have tried to concentrate more on total cholesterol, good cholesterol and incidence of high cholesterol. Now before I go on to what have been my major contributions and various policy implications, I would like to briefly tell you about the policy initiatives of WHO and various countries. The WHO, that is the World Health Organization, it started with a campaign of 5 a day. That is, you should have 5 portions of fruits and vegetables per day. That would be approximately, you could say, 400 grams of fruits and vegetables. Now, a portion, before we go further, I'll just tell you what exactly is a portion. One portion is equivalent to a medium-sized apple or one small glass of fruit juice, which is approximately 150 milliliters, and maybe 3 teaspoons of vegetables. So, the WHO went with a 5 a day campaign, which was further taken up by various countries. Countries like UK, Netherlands, Germany, Norway, they adopted the 5 a day policy, while some went for expansionary dietary policies like France, Australia, Canada, Denmark. So, for example, Australia, it went for 2+5 policy, in which it said that you should consume 2 portions of fruits and 5 portions of vegetables per day. And USA went for a policy of fruits and vegetables, more matters. That is, you must consume more and more fruits and vegetables. Now, irrespective of these expansionary dietary policies and dietary propagations, it has been found that only 28% of women and 25% of men, they actually meet the recommended dietary norms of 5 a day portion. So, the major contribution of my work is firstly to find an association between fruits and vegetables, whether there exists a relationship between fruits and vegetables and health indicators, and if they exist, whether due to heterogeneity in the data, so I will be doing it according to age, by gender and by your weight. So, apart from that, I will go for policy recommendations, in which I am basically studying how much fruits and vegetables matter. Apart from that, which type matters more. So, for that, I have taken data from the Health Survey of England. Health Survey of England is an annual survey which takes data, which conducts information regularly on demographic and socioeconomic characteristics. You have your lifestyle behaviors like an individual smokes or doesn't smoke, alcohol consumption, you have your sedentary and physical activities, and you have various health indicators also which have been collected. Before I go on to what exactly is my research, I would like to concentrate more on fruits and vegetables, like what kind of questions were asked in the survey. Questions like, what kind of fresh fruit do you eat? Did you eat any dried fruit yesterday? Don't count dried fruits in cereals, cakes. Apart from that, for vegetables, they asked how many tablespoons of vegetables did you eat yesterday? So, approximately after this whole survey was conducted, data was converted into portions of fruits, and like for example, 3 tablespoons of vegetables is equivalent to 1 portion. So, data was converted and provided to the users, that is us, from the UK Data Health Survey. So, the major contributions of my paper is that I found a strong negative association between intake of fruits and self-assessed health, then various measures of blood pressure like mean arterial pressure, high blood pressure, systolic and diastolic BP, and your total cholesterol. Apart from that, I have found a strong positive association between consumption of vegetables and good cholesterol. So, it is recommended in a way that if you want to control your blood pressure, you must consume more and more fruits. And as far as vegetables are concerned, they impact your good cholesterol. Apart from that, I went in for a falsification test. A falsification test is basically conducted to know whether the model that you have adopted and the conclusions that you are drawing are not spurious. So, if a falsification test is done to know, in a way it is tested by seeing an indicator, a health indicator, which is not being impacted by your consumption of fruits and vegetables. And then we see whether there is significant result or not. If there is no significant result, that means your model is good and your results are non-spurious. So what we did is, for falsification test, we took ear complaints and infectious diseases. Now ear complaints, like if you are deaf since birth, or you have some kind of imbalance, body imbalance, that is not being impacted by your consumption of fruits and vegetables. And we did find insignificant results. Apart from that, infectious diseases like HIV, AIDS, etc., we found similar insignificant results, indicating that our results are not non-spurious. Apart from that, we went, since there was a lot of heterogeneity in the data, like by gender, by age, and by weight, we did the regression analysis. We found results which stated that as far as fruits are concerned, it impacts a male's health more than a female's health. So it is basically said a man should consume more fruits to impact his health, whereas as far as vegetables are concerned, they impact a woman's health more. But this has been only seen as far as cholesterol is concerned, the various measures of cholesterol, like total cholesterol, good cholesterol, and your incidence of getting high cholesterol. Now, after this, we went in for a policy implication, and in the policy implication, we tried to find two policy implications: what matters and exactly how much portion matters. So as far as how much portion matters, we have found that on an average, 5 or more portions of fruits impact your overall health, that is your self-assessed health, your MAP, your incidence of high MAP, and incidence of high BP. But if you want to have a good mental health, so you can optimize your mental health by consuming 3 or 4 portions of fruits as well. And similarly, as far as self-assessed health and total cholesterol is concerned, an individual must consume 4 to 5 portions to optimally have the impact of consumption of fruits. Apart from that, vegetables have had a very little impact on your health. It only impacts your incidence of getting high MAP and high BP, and it's seen that only it impacts when you consume 5 or more portions of fruits. So an optimum consumption of 5 or more portions of fruits and vegetables are recommended, but fruits have a more impact on your overall health, on various measures like self-assessed health, mental health, your various measures of blood pressure, and various cholesterol levels. Another thing that we find is which type of fruit matters. It has been seen that all size fruits, they impact your self-assessed health, your systolic and diastolic blood pressure, your mean arterial pressure, your high BP, and incidence of getting high MAP and high cholesterol. But we find that as far as frozen fruits or canned fruits are concerned, they help in regulating your incidence of getting high MAP or high BP, but it has a trade-off. That means there is something negative happening. It reduces the good cholesterol in your body. Apart from this, if you have an incidence of getting high cholesterol, it is recommended that you must consume fruit juices, because it has a impact in reducing your probability of getting high cholesterol. And dried fruits, they impact your self-assessed health. As far as vegetables are concerned, very little impact has been seen. It has only been seen in case of portion of salads and its association with self-assessed health. Another thing that they have seen is vegetables in composite, they have an association with good cholesterol. So overall, my research basically says that there is an association between consumption of fruits and vegetables and various health indicators, and it is highly recommended that an individual, in order to be healthy, must consume 5 or more portions of fruits and 5 or more portions of vegetables per day. But fruits have a more impact on your overall health. Apart from that, all size fruits, they have a better impact on your overall health, your mental health, various measures of blood pressure and cholesterol. So, thank you.